In the next few segments, we're going to talk about the game Rock, Paper, Scissors. It's a game for two people. You simultaneously choose one of rock, paper, or scissors. And the idea is you do that by making one of these gestures. The gesture on the left is for paper, the gesture in the middle is for scissors, and the gesture on the right is for rock. And the idea is that paper will wrap a rock, so paper beats rock. Rock will blunt scissors, so rock beats scissors. And scissors will cut paper, so scissors beat paper. So the aim is you make a choice according to some rule or totally at random. You each do that simultaneously and then you get a result. And here I've got the computer playing against me. And you can see we're playing, and the computer's playing a random strategy, and I am choosing S, P or R for scissors, paper or rock. And after a number of plays, the computer has won. Let's think about how we could implement that. What we need to do to start with is think of a move data type. How can we represent moves as data? And what we're going to do is define a very simple data type called move with 3 items: rock, paper and scissors. Couldn't be simpler. We can make move visible. Now I've here defined the show function by hand, taking a move to a string, but as you know, I could have derived that so that I would have had I'd have had that function, the same function, derived automatically by the system. We want to be some mechanism for turning a choice of a character into a move, and here I've written a function which converts the characters R, whether small or capital, to rock, P, whether small or capital, to paper, and S to scissors. So we'll use that later on when we start processing input interactively. Now let's try and encode the rules of the game in a function. And let's do it like this to start with. Let's write a function beat. When given a move, will return the move that beats that move. So the way to beat rock is to play paper. The way to beat paper is to play scissors. And the way to beat scissors is to play rock. Now, you could write a similar function, which I'll leave you to think about, which takes a move and gives you the move that loses against the input move. So lose of rock would be scissors, because scissors lose against rock, and so on. Now something else we want to do is score a single round. I've written a function outcome that does that. Now what this does is take 2 moves and it returns +1 if the first move wins against the second, -1 if the second wins against the first, and 0 if they're the same. So you can see that I've written outcome rock rock is 0, outcome rock and paper is -1 because paper is the winner there, outcome rock and scissors is +1. I covered up the final 3 options, but you can work those out for yourselves. Now that's a bit cumbersome. Is there any way that we could try to write a formula that would somehow work out the outcome rather than having to write 9 cases? Well, let's see what we can do. What we do here is we've written a function that turns a move into an integer. So rock is 0, paper is 1, and scissors is 2. And you can see from here that the immediate successor beats its predecessor. Paper beats rock, scissors beats paper, So if we take their scores and the difference is +1, it's a winner. If they're the same, the difference in scores is 0. If they are if there's a difference of 2, then the first one is the higher one is the loser. So effectively what we want to do is take those two integers and subtract the second from the first. Now, if we do that, we're potentially going to get numbers between 1, 2, 1 and 0. Or in fact we can get rock minus scissors will give us -2. So we need to calculate to normalize them to the range +1, 0 and -1. And the way we do that is we add 1 to the difference, take the modulus and then subtract 1 again. And that ensures, because otherwise the modulus will give us a value between 0, 1 and 2, because it's modulo 3. We subtract 1 to make sure the difference is between 1, 0 and -1, but we add 1 before that in order to cancel out for the subtraction, if you like. We add before taking the modulus and then remove 1 afterwards, and that gives us our score. So there's a compact way of working out the outcome of a single move. What we do next is look at a tournament, a sequence of moves.